All right. So inequalities, we're going to just start with a couple review terms that you are going to see pop up with inequalities. By all means, do not write this down word for word. I would only write down what you feel like is necessary here. First definition, the solutions of an inequality are the real numbers that result in a true statement when those numbers are substituted in for the variable in the inequality. So pretty much anything that gives you a true statement is considered a solution. So when we see greater than and less than, there is a range of solutions. There is a lot of numbers in most cases that will give us true statements. So our solutions are going to be ranges of values. We can use inequality symbols to represent them. We're also going to see interval notation, what we did with our domains ranges in the last chapter, pop up again with this. There are three types of inequalities you can have based on what kind of solutions you have. First one is a conditional inequality. And conditional inequality has at least one solution and at least one number that is not a solution. So conditional means some are, some are. Okay, so we have at least one answer and at least a number in the real world that is not a solution. Inconsistent inequality. An inconsistent inequality is such that if there are no real numbers that make a solution. So if you get an answer that is no solution, we call that an inconsistent inequality. And we'll just use this symbol for no solution. Last one is an identity. An identity is an inequality where every real number is a solution. So the solution to an identity will be our all real numbers solutions that we've seen before. Negative infinity to positive infinity. Okay? So solutions are anything that works. Conditional is some answers work, some don't. Inconsistent, no answers work. And then consistent, or identity, excuse me, every real number works. Most of the time you will not have to be labeling with these. We'll just stop at all real numbers, negative infinity, positive infinity, or no solution. But you might see a Math Excel question that asks you which of the three types it is. So just be aware of these. Okay. One more second, and we'll do some examples solving our inequalities. Okay. So, examples. Let's start with these two. There's a reminder at the top. We've done this already earlier. If you multiply or divide both sides by a negative number, make sure you flip your inequality sign. First problem, 3 minus 3x greater than or equal to 15. What do I do first to isolate the x? Subtract 3. So then I have negative 3x greater than or equal to, if I subtract 3, I end up with 12. Next step, divide by negative 3. If I divide by a negative, flips my inequality sign, and I'm left with x less than or equal to negative 4. When you're listing your solution, we are not going to use less than, greater than symbols. We are instead going to use our interval notation. So equal to, remember we use a square bracket. Not equal to, we're going to use a parentheses. So this solution would be a parentheses, negative infinity, comma, negative 4, and because it's equal to a bracket. And then that's how you would be putting that in Math Excel. Graphing it on the number line. In the past, you've used a closed dot for equal to and an open dot for not equal to. Our number lines are going to match our interval notation now, which is where I kind of like it. So we're going to pick wherever negative 4 is, somewhere on the number line. We're going to make a bracket, closed bracket, square bracket, because it is equal to, and then we're going to shade to the left. Whichever direction the shading is which way your bracket or parentheses is going to open towards. Okay? That's it. Make sense? So these will always match one another. You could always do the number line first and then make the inequality parentheses bracket statement later if you like. All right, go ahead and try the second one on your own. I'll give you a minute. Solve it, graph it. Okay. These ones should hopefully be quick. So distribute first. that. We need to get like terms together here. I'm going to add my x over to this side, make it a 4x. I'm going to add my 9 over, make it a 12, and then divide by 4, x less than or equal to 3 you should have. If you moved things to the other side, you would have just divided by a negative instead, and it would have flipped that inequality. If you divide by a positive, you do not have to change the sign, only if it's a negative, or if you multiply both sides by a negative. So answer should be square bracket at 3, and then it's everything below is shaded. That's our x less than or equal to 3. So inequality is going to look very similar, negative infinity to 3 with a bracket for our interval notation. If you have this, that also means the same thing, right? In both of these, the inequality symbol is still pointing at the x, so it still means x is less than 3. This is fine. It just means you move things to different sides of the equation as you were solving. Okay? Good? Moving on. All right, so next. Let's say I give you some with fractions in them. As long as there is not a variable in the denominator, as long as it's just numbers down there, first, call it optional, but probably a good suggested step, is to clear the fractions. This problem's a whole lot easier if there are no denominators. The easiest way to clear a fraction is to multiply both sides by the least common denominator. And any denominator really would work, any common denominator, but the least one is going to make it so you don't have huge numbers as you're solving. So looking at this first problem, what is the least common denominator between the 3 and the 2? 6. So we're going to multiply both sides of this inequality, and I'll just put the whole thing in parentheses, times 6. So now we're distributing it in to all of our terms, here, here, and here. I would suggest, instead of distributing it into the numerator and then reducing, just reduce first. 6 over 3 reduces to what? 2. And then I would still have the quantity x minus 3. Less than or equal to 6 over 2 reduces to 3, and then there's still that x in the numerator, plus, now here I don't have a fraction at all, 6 times 2 just gives me 12. So first step made it a whole lot easier to solve. Now it looks like the previous problems. So I can distribute. Let's see, I'm going to move my 3x over here, so it'd be negative x. I'll move my 6 over, so it's going to be positive 18. Divide both sides by negative 1, it's going to flip my sign. So x greater than or equal to negative 18. I find negative 18 somewhere on my number line. It's a bracket because it's equal to. This time it's greater than, so I'm going to have to shade to the right, which means my bracket's going to open to the right, like this. And then that's going to match our interval notation, negative 18 to infinity is the solution. Okay? Mm-hmm.
The negative number when you go to infinity, but if it's positive, we start with negative infinity, like in the brackets.
This, it was shaded to the right, that's why it's a positive infinity. Negative infinity is over here, positive infinity is over here. So it depends where you're shading, where your solution is at. Does that make sense? Okay. All right, let's do the next one together. A lot of fractions in this one again. I have a 3, a 4, and a 12. What is the least common denominator? 12. So I'm going to multiply the whole equation by 12. Distribute all the way through into every term. First one, I have a 12 over 3 that reduces to 4, and then I still have 2x minus 1 greater than. 12 over 4 reduces to 3, and then I have an x plus 1. 12 over 12 just cancel, and leave me with an x. And again, it's a whole lot easier to solve now. Distribute 8x minus 4, 3x plus 3, plus x. Let's see, I've got a 4x technically on the right. If I subtract it over, it'll give me a 4x. And if I add the 4 to the other side, I'm going to end up with a 7. And then divide by 4, x greater than 7/4. On a number line, 7/4 is going to fall between what two integers?
1 and 2.
It's 1.75. Yeah, so 0, 1, 2. So if I were going to graph it, it would be somewhere between 1 and 2, rough estimate. It's going to be a parentheses or a bracket here. Parentheses and opening which direction? To the right or to the left? Which way am I going to shade? To the right. It's greater than parentheses, shading that way, then that's our answer. 7/4 to infinity, all with parentheses. Okay? Good? All right, so those are basic inequalities. Next are compound inequalities. So this is where you have two inequalities put together with either an and or an or statement. Or, when you see it, means union, which means both of the inequalities put together. Anything that is a solution in one or the other is a solution for the entire inequality. Okay? If you see the word and means intersection. So our solution is only what the two inequalities have in common, where they overlap. So or is everything put together. Doesn't matter if they overlap or not. It's a solution to one, it's a solution to the whole. And is intersection, only what they have in common. Okay? We'll do the first one together. So it's going to look something like this. You're going to see two smaller inequalities, just like we solved a moment ago, and you're going to see now this compound word between them, either an and or an or. First one, I'm just going to solve these each individually. 3x minus 5 greater than or equal to 7. What's my first step? Add 5. So 3x greater than or equal to 12, and then divide by 3, x greater than or equal to 4. Nothing crazy there. Next, solving this guy. Subtract 5 on each side. So I'll have negative 2x greater than or equal to negative 4. And then divide both sides by negative 2. It's going to switch my inequality sign. X less than or equal to positive 2. And I'll just bring down my or statement. Or means if I have it shaded for either of those inequalities, it's a solution to the whole. So I like to shade these ones first, because it's going to kind of tell you what your interval notation is going to look like. Just graph them both on the same number line. Whatever happens, happens. If they overlap, great. If they don't, that's fine too. X greater than or equal to 4. I find 4 on my number line. Greater than or equal to, so I need it to open to the right, and I need it to be a closed square bracket, shading to the right. That's the first piece. X less than or equal to 2, I find 2 on my number line. Again, it's equal to, so I'm going to use a square bracket. This time it opens to the left, shade to the left. Okay, so now if I want to list that solution, I'm just going to, in interval notation, list out everything that's shaded here. So this would be this little piece, negative infinity to 2, square bracket, my union symbol, because I've jumped over that 2 to 4 range, and then 4 to infinity. So that's your solution. Okay? I want you guys to try the and statement. Only difference is when you graph on the number line, the only thing you want to graph is what the two inequalities have in common. So if you need to, you can do two smaller number lines first, and then only graph on the final number line where they would overlap at. That's really your solution area for the and statements. Okay? So I'll give you a minute. Go ahead and try it. What did you get as a solution for this first one? X negative 1? 1? Okay. And what about the second one? X less than or equal to 3? Good? Everybody okay with getting those? All right. So now if I want to think about these separately, maybe think about another little number line here. X greater than negative 1 would be a parentheses at negative 1, and that guy would be shaded to the right. Correct? Yes?
Can you still put points like by
I don't want any dots. No. No dots. Just parentheses bracket. I know, it's different than what you're used to. No dots. Less than or equal to 3 would be a bracket at 3, opening to the left, and shading to the left. So if this was an or statement, my answer would be all real numbers. Everything on the number line is shaded. But because it's an and statement, we only care about what they have in common, so the parts that were shaded twice. What part was shaded twice on the number line? Negative 1 to 3. Negative 1 was a open circle parentheses, so it stays that. 3, same thing, will stay a bracket. And then your final answer here, this is what your number line should look like. It's only the part where those two inequalities would overlap at. Okay? And then that's your interval notation too. The number line makes it really easy. -1 with parentheses, comma, 3 bracket. And then you can check these. Any number that's in this interval should give you a true statement in both inequalities. So like an easy number to plug in would be 0 here. You can plug 0 into both inequalities and make sure it gives you a true statement both times. That'd be a way to check it. Okay. All right. So last couple problems. Combined inequalities. Combined inequalities are a fancy way of saying and. These are and statements in disguise. When I see something like this, it means the part in the middle is greater than -1 and also less than or equal to 0. So you can leave it like this if you want, or you can split it into two different pieces. I'm going to leave this one as it is because I think it's easier to solve if you leave it instead of splitting it, but I'm going to split that second one and you'll see why in a little bit. All right, if you want to solve a combined inequality as it is, treat it like an equation. We want to keep everything balanced. The only difference now, there are 3 pieces, so we need to balance 3 pieces. If you do something to one piece, you need to do that same thing to the other 2 pieces of the inequality to keep it balanced. Focus in the middle where your variable is. What's the first thing you need to do to isolate that x? What would you get rid of first? The 5, for sure. That makes it gross. So how do I get rid of the 5? Multiply everything by 5. So that'll give me -5 less than 2x minus 3 less than or equal to 0. What's the next thing you would do to all 3 pieces? Add 3. Plus 3, plus 3, plus 3. So then I have -2 less than 2x less than or equal to 3. And then last step, divide by 2, divide by 2, divide by 2. So then I end up with, my inequality sign's not changing, -1 less than x less than or equal to 3, which means pretty much x is between -1 and 3. Now the only time you're really going to cause an issue here is if your inequality symbols are pointed the wrong direction. But that's not 3. I see Logan like, that's all right. 3 halves. 3 halves, that's better. The only time you're going to run into an issue here, make sure your inequality symbols are pointing at the smaller number. If my inequality symbols were pointing at the 3 halves is not less than -1. This whole thing would be an untrue statement, so there would be no solution. So you just want to double check that when you have these, inequality symbols are pointing in the right direction. This means my x, my solutions, are any number between -1 and 3 halves, and then that's what it's going to look like when I graph it on my number line. -1, 3 halves, wherever that's at, 3 halves is going to be a bracket. And again, it's an and statement, so anything between them there is going to be where I would shade, and that's what your interval notation is going to look like, -1, comma, 3 halves, bracket. Make sense? Okay, so now for the second one, let me show you what this would look like if you split it apart. The reason I would want to split this one apart and not do what we did over there is there's a lot of x's. To be able to isolate an x is going to be very difficult here. When we have 2 pieces, it's easy to start moving things from one side to another. But when you have 3 pieces, like let's say I want to subtract 3x from the middle. Well, sure. Then I have to subtract 3x here and subtract 3x here. Okay, well now I have 2 x's. But then if I want to, I don't know, take this 4x and move it over, I mean, you're constantly playing with, I'm taking one away here, but I'm adding it 2 places here. It's really difficult to get them all together when there's 3 sides. So instead, we split it. The middle part is going to be in both of your inequalities, 3x plus 1, 3x plus 1, and that middle piece has 2 conditions on it. 3x plus 1 needs to be greater than 5x, and 3x plus 1 needs to be less than 4x minus 2. So this is what it will look like if you split one, and then again, it's always an and statement here. On the left one, how do I solve for x? Subtract 3x, so I'd have 2x less than 1, and then divide by 2, x less than 1/2. And over here, I'll subtract 3x over, just gives me an x, and then I'll add 2, gives me a 3. Good? Okay, so again, an and statement, you can think of your number line. I have x is less than 1/2, so I find 1/2 less than, parentheses, opening to the left would shade this way. This is x greater than 3, so 3 parentheses opening to the right, shade that way. If this was an or statement, both the pieces that were shaded would be part of my solution. But it's an and statement, so we're concerned about what they have in common. What do these two pieces have in common? Absolutely nothing. So my answer is no solution. If I'm asked to graph that on a number line, I leave my number line blank because there are no solutions. Okay? All right, last slide for the day. We're going to do the first one together. You're going to see a math Excel problem like this. You are given a combined inequality over here. A less than or equal to 3x plus 5 less than or equal to b. And you are told x is already, you're told the solution. X is between -3 and 2. That's the answer. We're trying to work backwards to figure out what the original a and b are in the problem. What were the original restrictions on 3x plus 5? My hint to you here is start with your known, this guy, and make it look like that guy. If I can make it look like that, what I have at the end, I'll be able to see what those a and b values are. What can I do with this middle piece, x, to make it look like 3x plus 5? What would you do first? Add, subtract, multiply, divide. Okay, I need to multiply by 3 and I need to add 5, right? Which one should I do first? You should multiply first. Times 3, times 3, times 3. So I have -9 less than or equal to 3x less than or equal to 6. Now I need to add my 5. Plus 5, plus 5, plus 5. So then I have -4 less than or equal to 3x plus 5 less than or equal to 11. So now it looks like what my original statement was supposed to look like. A less than or equal to 3x plus 5 less than or equal to b. So in Math Excel, you're going to have to enter what's A and what's B. What's A? -4. And what's B? 11. Make sense? Last problem. You guys do it. Assume x is between 3 and 7. Find the real numbers a and b so that a is less than or equal or less than 1 minus 3x. That's less than. Okay. If you're having trouble with this one, trying to figure out to make how to look like this, you can always think of this like -3x plus 1. This is the same thing as that middle there. The 3x is negative and the 1 is positive. So that's what you're trying to do. These are your steps. You're multiplying by -3 first, which if I multiply in an inequality by a negative, what's going to happen? Signs flip, right? Do you remember to flip your sign? -9 greater than -3x greater than -21. And then I'm going to add 1 to everything. So it'll give me a -8. It'll give me a 1 minus 3x, or you could write -3x plus 1. And if I add 1 to this, it's going to be -20. And then you'll know if you forgot to flip your signs because your inequality symbols will be pointing the wrong way. They'll be pointing at a number that's larger, and they should be pointing at a smaller number. Now be careful here. In what I see versus what I started with, the inequality signs are flipped. So what is A? -20, it's the smaller number. And B is negative 8. Okay? All right. So that's it for our lesson today. Before you put your notebooks away, I want you to take, I don't know, 4 minutes at the max. This will take you. These are the steps that we are going to be using on Monday to solve a polynomial inequality, which is an inequality higher power, squared, third power, fourth power, and then a rational inequality. Those are fractions where you've got variables in the denominator. Paraphrase if you want, but put these in your notebook for Monday, so then Monday we can just get straight to our examples and get those done. So as soon as you're done for the day. Just write it down. I get this for Monday's lesson, and then I'm going to do the self-one lottery for you guys. If you want to be working on your homework, like I said, this assignment is not due until next Thursday, but you can do all the linear stuff. As long as there's no powers on x or x in the denominator, you can flip through and do all those other assignments, all those other problems in the assignment. Self-one lottery linear is 1 today. All right.